So right here you have a battery and a bulb, and the total current for this whole circuit is 2 amps, and the total voltage is 9 volts. So when you add an extra bulb, the voltage is shared between those two. So this was 9 volts. The bulbs are identical, so they have same resistance. So the voltage is 4.5, 4.5. If the voltage were different, it means that the bulbs have different resistance. So if you have two different type of bulbs, the voltage will be shared differently. But the main point is the sum of the voltage will equal to the voltage of the battery. If you look at the current was 2 amps before. Now it has gone down to 1 amp. So if you think of it as water flowing through, there is more barriers now. So the overall flow is not big as before. So the current has dropped down. So the total resistance from here to here has increased. But the total voltage is still 9 volts, still 9 volts. So if I fill in the value for one bulb, so that's that circuit, it's 9 volts across, and total voltage is 9, and the current is 2 amps, and the total resistance is voltage divided by current. So use the ohm symbol. It's just hard to get an ohm symbol on this, so it looks like the funny Greek symbol. And the total power will be total current multiplied by total voltage. So this setup has 18 watts of power. So it's using 18 joules per second, this bulb, converting from electrical to light energy, and also some heat. It's the same table as before. Note that I'll repeat it again. The ohm should be a symbol, the Greek symbol. And try to put units on all of the numbers you have. So I should have put volts, 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 volts. So you have two bulbs in parallel, and so the voltage across each of the bulbs is 9 volts. So it's same as across the battery. So the total voltage is 9 volts here, 9 volts here. So this is the same for series circuit. Total voltage is still 9 volts. But in this case, the voltage, 9 volts, stays the same for this branch and this branch. So the voltage is not shared compared to the series circuit. So before, in series circuit, the current is same throughout the whole circuit. But in this case, the current branches out. So you can think of it as pipes. If this pipe splits, then the water has to flow in two different pipes. So if you put an ammeter onto this branch and this branch, it will read 2 amps. So let's look at the total voltage. So to measure total voltage, you need to put the ammeter on here or here, and it adds up to 4 amps. So it's sum of these two currents. So it's 4, splits into 2, 2, then it backs back to 4 again. If you look at the power of each of these bulbs, so there's 2 amps flowing through and there's 9 volts. So 9 times 2, 18 watts. Same for this bulb. So now you have two 18 watts bulbs. So the total power of this circuit is 36 watts. So as you can see, this is using more energy. So this kind of circuit is what you will have in your home. So advantage of this setup is if one of the bulbs break, then the other one still works. Compared to a series circuit, if one breaks, the whole circuit stops. So that's one of the reasons why we'll have that in our homes, this kind of circuit. Okay, now let's look at the total resistance of the whole circuit. So that is total voltage divided by the total current. And notice that the resistance has decreased. So since the total resistance has decreased, the total current has increased. So you can think of it as there's more paths for the current to flow, so there's less resistance. So the current has increased.